Hello everybody, I'm Kumar Singh. Welcome back to my channel and the series of Node.js core concepts. So today I will be showcasing the code demonstration of how synchronous and asynchronous codes get executed in Node.js. Before moving to the directly the code, let's understand what is synchronous and asynchronous code. Any line of code that executes sequentially and it blocks the execution of another line of code below that line is called synchronous code, and any code that runs parallelly and doesn't blocks the sequence of code is called asynchronous code. From the above statement, we understand that synchronous code is blocking while asynchronous code is non-blocking. So let's quickly dive into the code and understand how the synchronous and asynchronous code behave in Node.js. We are in a code. Now we see here we have lots of function that is defined. I have already defined this function so that it will be easy while I'm providing the code demonstration. Here I find it there is a synchronous and asynchronous function, both are defined, and I will show you how it will works in each place. So first of all, we'll start with the synchronous function. So I'm commenting out the async function call, and that directly we are calling the synchronous function. Now we'll see what is inside a synchronous function and try to understand how it get executed. So as we know, synchronous function or synchronous code get executed in a sequence, right? So we'll start with the code now. So we have uh, synchronous and asynchronous function, both are defined here just for the common code demonstration purpose. So we'll first of all execute the synchronous function, and then we'll check all the behavior of the execution of the code inside a synchronous function. So inside a synchronous function, first of all we have defined a async callback function, which is generally now written as a synchronous, right? Inside that particular async callback function also we don't have any asynchronous call. Right now we have asynchronous, and then later on we'll modify this asynchronous callback function to asynchronous code, just to demonstrate how asynchronous code will behave there. So after that we are doing a console log, and then we are calling the read file sync function, which is a built-in function, which is the basically a function inside a fs module that will basically read a file in a synchronous way. And then we have then we are doing the console log of the data that is fetched from the read file command, and then we are doing the console log again just to check how the execution of code behavior. So uh, let's execute the synchronous function now. So in this example, you see we are now calling the synchronous function from the root module. Now we'll execute the code and we'll see how the code moves from top to down and how the line of codes get executed inside a synchronous function. So inside a synchronous function, first of all the async callback example function is called, and inside that particular function we have all the synchronous code. So we see the sync console get printed first, and then we are not printing this sum, so we are calling this callback function. Inside that callback function we are again printing the 5 plus 4, that will give us the 9, and we see the sequence, it is in a sequence like sync console and then 9. So this execution of line code is done. After that we got check 0 as printed, yeah, and then we are reading this file, and inside that file we have nothing, just one line of sentence that is file read, and we have printed that thing here. And after that again we are printing the check one, and that is the last line of code inside a synchronous function. So what we find here, everything get executed in a synchronous, and whatever the print console log we have added inside those functions, they are getting printed in a particular sequence from top to down approach. Now the same way we'll see how asynchronous function will work here. So we are right now commenting the asynchronous synchronous function call, and then we uncommenting the asynchronous function call. Yeah, first of all, we are in the inside a asynchronous function. We are first of all reading the file in a asynchronous way. If you see, here we have not used the read file sync function of the fs module. Rather than we are using read file, which is asynchronous, and we are taking the callback of that particular read file function, and inside that callback we are just checking if there is a error, then it will print the error, otherwise it will print data inside the file. After reading the file, we have the console log written there. So and then we are calling the async callback example function, same function, right? And inside this async callback example function we have everything synchronous code. So right now we haven't added any asynchronous code inside it. So let's check how it behaves. Now when we execute the function asynchronous function inside a root module, what we find, first of all, async function get executed, which is the second code that is supposed to be executed inside a async function. So what happened actually, the fs read file get executed first, it moves to the call stack, and after that it moves, since it is a asynchronous code of reading the file, it moves towards the libvirt thread pool, where it is used, the thread pool is thread one of the thread from the thread pool is used to execute this code. After that, so it becomes a asynchronous, so it's not blocking our next line of code. So what we found, the async func that is that is inside a console log get printed first, if you see this one. After that, what happened, we are calling this function, which is also asynchronous. Inside all the codes inside that function is asynchronous, and we see it has printed sync console. We hear there is a sync console inside a console log, and then it has printed 9, which is inside a callback function, which is here. And because it is called from inside that async callback example function, so it will print that. So 9 get printed here. Now at the end, what we found, the read file output is there. The content inside a read file get printed at the end of the code, even it is written at the first of the asynchronous function. Since it is a async task, it get executed inside a libvirt thread pool, and once it is done, then only the data inside that particular file get printed. So we see here this console log data, which is identified by file async1, get printed at the end. So from this code demonstration, what we found, that synchronous code is always blocking. It blocks the lower line of code execution, whereas asynchronous function doesn't blocks the below line of code execution. It allows the below line of code to get executed. Meanwhile, the call stack and event loop is executing the asynchronous task, and once it is done, then only it will gives the output. So this is a very basic example. We'll write some more code here inside the asynchronous function, just to understand how it will behave, how the asynchronous code is behaving one by one. So right now we have added this async callback, which get printed in a synchronous way. this AC callback example function, because inside that particular function also we have written the synchronous code, nothing asynchronous. Let's write some asynchronous code inside that inside AC callback example function, and then we'll see how it behaves. So before calling this callback function, we'll write here some asynchronous code. We can use the same set timeout function, and we are doing the console log inside set timeout function, and we are putting here uh, a delay of 300 milliseconds. So now after putting this particular line of code, we see little bit the format get changed. What is showing right now, first of all the async function sync console, okay. So for this one is get printed first. After that we call this function. Inside this function we have a synchronous code which is console log that will print the sync console. That gets printed in the second place. After that we are getting the 9 as a printed. So this is a callback function where we have synchronous code and where we are printing the 5 plus 4, the addition of 5 plus 4, which get printed first. After that this set timeout get the callback of this set timeout get called, and in after 300 millisecond it prints set timeout function called. That means it's not blocking the lower line of code. That is the one thing. Meanwhile we can see here, before it moves to the, since we have added here 300 millisecond uh, of delay, so it will, anything inside a callback of set timeout will get printed after 300 millisecond. We find it before that, that particular execution of the callback, the task inside a read file, that means the reading of the file task get executed first, that means get completed first, and it get handled by the call stack first. And we found that the file read statement get printed first. After that only set timeout function, which is inside a callback of the set timeout function, get printed. What we found here, if even we have a multiple asynchronous call inside a particular script, then it depends upon the response of that particular functions, depends upon how quickly the given task get executed in the event loop. So we see here the read file, the response of the read file gets printed first. After that only the set timeout function callback get executed, because there is a delay of 300 milliseconds that we have provided. Well, guys, today we have explored the execution of synchronous and asynchronous code. Also, it is known as blocking and non-blocking code. By understanding the execution of order of execution of code, we can now write more efficient and effective code. Remember one more thing, we need to understand in which particular scenario we have to use the synchronous and asynchronous code. So as we see, since synchronous is blocking code, wherever we have the dependency of the upper line of code to the lower line of code, then we can use the synchronous code. And in the place where we don't have a dependency, we can execute those code parallelly, and then we can use their response. In that particular scenario we can use the asynchronous code. Also one more thing, synchronous code is time consuming. That means it blocks the main thread. So So many times or multiple scenarios our CPU are idle for that particular time period when it is not being used by the CPU itself. For example, reading a file at that particular point, the CPU is not involved, even that is waiting for the completion of that task. And code can be used for in the scenario like we are calling some kind of third party API from the Node.js. We can call them those APIs in a parallel way even as we don't have a dependency. If we have a dependency, then obviously we have to switch back to the synchronous way, and then in that particular scenario we use promises or async await there just to get the synchronous flow. So I hope from the today session you have learned lots of things. Meanwhile, if you have liked this video, then please hit the like button and subscribe my channel. Until then, keep coding, keep exploring.